This episode of Serverless Chats is sponsored by Hexagon. This week, I'm chatting with Susanne Kaiser about better serverless microservices using domain-driven design. This is Serverless Chats, episode number 42. Hi everyone, I'm Jeremy Daly and you're listening to Serverless Chats. This week I'm chatting with Susanne Kaiser. Hi Susanne, thanks for joining me.
Hi, thanks for having me.
So you are an independent tech consultant, so why don't you tell the listeners a little bit about your background and what you've been up to lately?
So as an independent consultant, I'm helping organizations within the broad spectrum of software architecture and design, including development to software delivery, or in other words, or in shorter terms, helping organization building and shipping their digital products. And I was also previously working as a startup CTO, and I have a background in software development and software architecture of more than 17 years. And I also regularly present at international tech conferences as a speaker.
Well, speaking of international tech conferences, I saw one of your talks at Serverless Days Belfast before we've shut down all conferences, so no one can get together in person anymore. And you did a talk about domain-driven design and how that applies to serverless and serverless microservices. So I'd love to talk to you about that today because I think that is one of those things where software developers, I don't want to say all software developers, but a lot of software developers are just really bad at software design, right? And not just design of architecture and things like that, which are kind of in our wheelhouse, but more from the business side of things and understanding what the business needs are, understanding what the technical needs are, and then sort of where that comes together in the middle and what people should actually be building to solve those customer needs. So I think that is sort of domain-driven design in a nutshell, but maybe you could tell the listeners a little bit about what domain-driven design actually is.
So domain-driven design is a software philosophy or methodology created by Eric Evans. And it's about to capture the business domain as closely as possible into your software. And it comes with a lot of strategic and tactical design patterns and practices that I'm happy to share with you in a moment. But it's also I would like to mention also from the very beginning, it's not applicable everywhere. So you should focus on your core domain. I will explain it in a minute, hopefully too, where it makes sense to that focusing on complex business logic and helps you with solving problems that have complex business logic behind.
Yeah, and so you had mentioned in your talk the cost of poor software quality, and the number you gave here was I want to say it's $2,840 billion dollars a year in poor software quality. So what are some of these indicators of poor software quality?
So there are no simple measures for bad or good software quality, but there are several metrics that can be used as indicators. For example, an increasing curve of defect trend over the time is an indicator of poor quality software, or low test coverage, assuming that there is good test quality, or cyclomatic complexity, or large depth of inheritance and a high degree of class coupling could also be indicators. And also the amount of effort it takes to understand a piece of code, or badly engineered software resulting, for example, from immature, undisciplined practices and using less qualified software engineers. Or also, in one thing is also really important to mention is the lack of domain knowledge, and also poor communication and coordination issues in teams, specifically when the teams are growing.
Yeah, so that lack of domain knowledge. So I think that sort of gets to the crux of it, right? Because like I said in the beginning, we think we know how to solve a problem, and we know how to solve it technically. But what we're really trying to do is solve a problem that's very specific to a group of customers, whether that, whatever that group of customers might be. And those different models could be, your inventory system, right? And your inventory teams think of they think of inventory in a certain way. And then you need software engineers to be able to build a system that makes sense for them, that uses the same language, that uses the same sort of communication patterns or styles or things like that. So what are those, so what goes into building good software then? Like, what are the main components of building good software?
So yeah, domain-driven design comes with a core statement that in order to build better software, we have to align its software design with the business domain, with the business needs and the business strategy. And so domain-driven design helps you with aligning your software design with this business domain and needs and the strategy. And it's very crucial for building your software solution, because otherwise you are building something that, for example, are not matching the requirements of your users. Instead, you have to collaborate with intensively with your domain experts to gain domain knowledge and to understand the business, the problem first before you're solving it. And we are tending to jump directly into solving a problem technically, and we can just let's deploy it on a Kubernetes cluster, but we have not understood the problem first, and that's really crucial to build better software.
Well, you mentioned the word strategy, which is one of those things where I don't think a lot of people know what that exactly means. Like, what is the strategy? And you had talked a lot about Wardley Maps and sort of understanding this landscape and being able to use that to sort of plan your strategy. And we can get into some of that more. But can you explain Wardley Maps? We've talked about it before, but just sort of in the context of domain-driven design, how does that help you?
Yeah, I really like to combine domain-driven design with Wardley Maps, because at first, like when you start the journey to domain-driven design, it's really overwhelming. So it was, for me, very overwhelming, because it comes with a lot of new terms, and it requires some time to grasp and understand it. And since it's not applicable everywhere, Wardley Maps helps you to visualize the journey to domain-driven design. So Wardley Maps has been created by Simon Wardley, a researcher from the UK, and a Wardley Map is a representation of the landscape a business is operating in. And it's really simple. So it consists of an y-axis for the value chain and an x-axis for the evolution stages. And Wardley Map visualizes the evolution of a value chain. So the first question is, so what is a value chain? So behind every user need, there is a value chain, and it starts off with the questions like, who are your users? Who are going to approach you to get the problem solved? And what kind of user needs do these users have? Like, what kind of problems they would like to get solved by you? And what are the components and activities that are necessary to fulfill these user needs directly or indirectly by facilitating other activities? So, and you have on the y-axis at the top, we have those components and activities that are visible to your users, so where your users are touching your system. And at the bottom of the y-axis, it becomes more and more invisible to the users. And while you have to identify every component and activity that is that your value chain is composed of, you take this components and activities and plot it along an evolution axis, the x-axis, going from left to right. And at the left of the x-axis, we have genesis with brand new things that have never existed before, then custom build, then product and rental, such as off-the-shelf products or open source software, and then on the very right, like commodity and utilities. And the movement of a component or activity along the x-axis is determined by its stage of evolution. So it comes also with, Wardley Maps comes also with patterns and principles too. And for example, one of the pattern is that the map is never static but very dynamic. So everything evolves from left to right through the forces of supply and demand competition. And as the components evolve from left to right, their characteristics change. For example, from the uncharted domain from the left, the undefined market, it's uncertain, unpredictable, constantly changing, and becoming more and more industrialized, going to the right, where we enter the domain or the market of known, mature, widespread, commonly understood market itself. And also, one other pattern is like that efficiency enables innovation. So that means that the industrialization of one component enables the, for example, new features of existing products to appear, or the evolution of other components, or that new components can emerge, enabling new user needs. And so the evolution of one component and its efficient provision enables the innovation of others. But also it comes with principles, for example, that you should use appropriate methods per evolution state. So what components should be built in-house? These are the components that are residing in the genesis and the custom build evolution stage, or where to use buy off-the-shelf products and open source software. So that are the components and activities that are residing in the product and rental evolution stage, and where to outsource to utility suppliers. And these are the components and activities that are located in the commodity and utility evolution stage. So, and it's really important and in order to know to use the appropriate methods, because it's also we would like to avoid to custom build commodities, because we would like to custom build those components and activities that belong to our core domain. And that's why I can make then the link to domain-driven design later on. But it's also important to know your users and focus on your user needs. And because the user needs that are the subject area of what we build software for, right? They are the reason, that they are the why of our business domain. And but before we develop a solution that solves the user needs, we need to understand the problem domain first. And that's why I would like to bring in domain-driven design. But
before we get to that, though, because I don't want to get too far ahead, because I think that what you just said, again, like I said, we've talked about Wardley Maps quite a bit before, and this idea of moving from this custom built stuff to all the way up to where you just outsource it and it's electricity, right? It's a complete utility. This is really where I think serverless comes in with how we're planning on building some of these products, because it always used to be, again, you write some custom software that did something. Like right now, it would be crazy for someone to write their own database software unless, for their own company, unless they were building a new product. But if you need a database, you're not going to say, I'm just going to write my own database software. Like that's done. Like there is a lot of solutions out there, and you're going to pick something off the shelf and you're going to run that. And then it even has gotten to this point now with a lot of the tools that AWS has, is to say it would be crazy for you to install your own MySQL cluster, for example, on EC2 instances or on VM somewhere. That would just be crazy, because you have RDS, and that whole process is not only commoditized in terms of the software that's running, but then almost sort of a utility at this point by running the actual RDS cluster in the background and managing all the updates and all that kind of stuff for you. And that's sort of that great, when you had mentioned this, you said this idea of building versus buying versus outsourcing. This is the thing where there are so many pieces of the infrastructure now that have become commoditized in a sense, whether that's SQS or it's even compute with Lambda or Fargate or things like that, that now really I think we're at a time where as technologists, we can focus on building just the things our customer needs and let all that heavy lifting go up to the cloud provider. Yeah, exactly. So it shifts the focus back on the things that are really important to our business and to our customers, right? So instead of handling all these infrastructure and operational complexities without serverless, for example, for example, if we're a small team and handle all these infrastructure and operational complexities all by ourselves, then we don't have time to solve our users' problems and to focus on our core domain and provide and focus on our competitive advantage. Instead, our focus is blurred away and handling all these infrastructure and operational complexities. And with serverless, we have the possibility to shift our focus back, solving our users' problems first, and getting, as you mentioned, the undifferentiating heavy lifting, then outsource this to cloud providers using serverless technologies, for example. Right. So I interrupted you. You were getting into more about domain-driven design. Exactly. So one of the principles that's of a Wardley map is that we know our users and focus on our user needs, and because that's the why of our business domain, right? And but before we develop a solution, because I can talk
of myself, I tend to jump in right into the technical solution without understanding the problem first.
Right. I think a lot of us do that. Yes.
Yes, exactly. Oh yeah. like first trying to wire something together, and then oh no, it's not really matching the requirements that our users are looking for, and so we need to understand the problem domain first, and that's where I would like to bring in domain-driven design, where the collaboration between the domain experts and development teams is an essential part to obtain domain knowledge, and which is described in terms of the shared language, the ubiquitous language. And the domain knowledge is really free of any technical terms itself. It's just the shared language between domain experts and the development team. And the domain knowledge is very crucial because, as mentioned earlier, the lack of such can have a huge impact on costs caused by poor quality software.
Right.
So that's the reason why.
I was just going to say that the that's one of those things you keep talking about, these sort of two sides, right? You've got the domain-driven model, or the domain expertise, and then you have the technical expertise. And so in terms of taking an approach to building a product, right? There's that, and this is something you mentioned in your talk, where there's sort of those two sides of it, right? There's the strategic design side, and then there's the tactical design side. So maybe we could get into those a little bit.
Exactly, and that's also why where I would love to combine it with Wardley Maps, domain-driven design, combine it with Wardley Maps, because so domain-driven design comes with patterns and practical practices, and those can be categorized into strategic design and tactical design patterns and practices. So, and when we enter the field of strategic and tactical design, I would like to combine it with Wardley Map and use the y-axis to visualize that position and the value chain going from top, the strategic design, to further down the tactical design patterns. And as I mentioned before, we tend to jump directly into the tactical at the bottom first before we have covered strategic design. And I would like to avoid it by putting Wardley Maps in place, starting from top to down, starting with the strategic design first. And so we start at the strategic design within the problem space first. And that's where we analyze the problem domain and discover subdomain and the subdomains. And the problem domain or business domain is a business overall activities. For example, the services a business is providing to its customers. And the problem domain is composed of subdomains. The subdomains represent a set of interrelated use cases or business processes where, and we are distilling this problem domain and partitioning into smaller subdomains. And by partitioning the problem domain into smaller subdomains, we are, on the one hand, reducing complexities. But on the other side, we also have to consider that not all subdomains are equal, and some subdomains are more important and more valuable to the business domain than others. So we have three different kinds of subdomains. So we have the core, the supporting, and the generic subdomain. And the core subdomain, that's the essential part of our problem domain, providing the competitive advantage. That are those parts of the system that makes it a success and should be hard for competitors to copy or imitate. So they're supposed to be quite complex. They're supposed to have a complex business logic, and they tend to change often. So, and that's the core domain. That's where we have to strategically invest most and innovate on. And that's the subdomain we need to build in-house. And that's the core domain that's supposed to go into the genesis and custom build evolution stage of a Wardley map. Mm-hmm. So, and then the other subdomain type that we have is a supporting subdomain. So that helps to support the core subdomain, but does not provide any competitive advantage. So they are quite simple, but do not change very often. And if possible, you should look out for buying off-the-shelf products or open source software. And if that's not possible, for what reason ever, you're supposed not to invest heavily in these systems. They should be quite simple. But so these are the supporting subdomain that should go into the product and rental evolution stage of a Wardley map. Then the generic subdomain, are subdomains that many large businesses have, for example, authentication or payment handling or something like that. So they aren't core usually and provide no competitive advantage, but the businesses cannot work without them. So you cannot work without authentication in the most cases. But they are generally complex, but they are already solved by someone else. So the generic subdomain is supposed to go into the commodity and supplier evolution stage of a Wardley map. So we should focus on buying to outsource it to utility supplier, or if that's not possible, at least have it then, for example, they can be combined, like going into the product and rental or commodity and utility evolution stage. So either buy off-the-shelf products or use open source software or outsource to commodity suppliers. So that's how I would like to handle the strategic design combined with Wardley Maps. And further down, when we go further down, we enter then the tactical design patterns that I will probably talk later about it, like that supports making low level design decisions to architect and implement a solution. And but first when we go from top to down, we should start with the strategic design first, and then go further down into the tactical design later. Maybe it's not necessary to use the tactical design, but at least we have to understand the problem domain first using the strategic design. So after we have analyzed the problem domain and distilled the problem domain into subdomains, and also discovered our core domain where we have to strategically invest most, we can go further down and switch to the solution space of strategic design. And that's where we come to the domain model and later on to the bounded context. So the domain model is at the center of domain-driven design. And within each subdomain, a domain model can be created representing the domain logic and the business rule that are relevant to that area of the system. And the domain model comes in different shapes. For example, it's in the beginning, it's formed as an analysis model during the collaboration between the domain experts and the development teams. For example, it could be a UML diagram or product sketches. And later on, it can result in a code model when we come to the tactical design. And the domain model is described in terms of ubiquitous language and is free of any technical complexities. But a domain model cannot exist without a boundary, and that's where we come to the bounded context.
Before we get into that though, because this is one of the things that I think some people get hung up on, it's this idea of ubiquitous language. So I think I mentioned this earlier, but I think we should be clear on what exactly we mean by that, because I think for a developer, if you say this is a customer or this is an order, like that seems pretty straightforward, but to a domain expert, something that is, say, a particular status of something, like an order that is pending, that may mean something completely different to a domain expert than it does to a developer. Like a developer says, "Oh, the order's pending. That means I just flag it with a pending status." But there could be a whole bunch of other stuff that's involved around what may seem like a very, very simple term. Can you expand more on that ubiquitous language thing? Because I think that's really important.
Yeah, so it's also like to build in the common understanding, the shared understanding of the domain itself, and through the collaboration, intensive collaboration between the domain experts and the development teams. And during that collaboration, so this misunderstanding has to be cleared out. Like, for example, what do we understand for, like, what is a pending status? Like in terms of, it's not only a flag in a database. It also comes with business rules. For example, if an order is pending, then it means, for example, we cannot delete it or something like that. So there are some invariants that we have to check, and that are applicable to specific to its domain model. And so that means that it comes with a lot of new with business rules or invariants. That's what they call it in domain-driven design. And we have to make it sure that we keep the domain model consistent and to protect its integrity. within this bounded context. And so that means that not only a flag, but also it comes with with a lot of rules and invariants that we have to check.
All right, I interrupted you. You were talking about bounded contexts.
Yes. So as mentioned, that a domain model cannot exist without a boundary, then that's where we come to bounded context. And a bounded context provides different types of boundaries for a domain model. So it could form a consistency boundary around the domain model and protects its integrity. And it could also form a linguistic and semantic boundary, so that the language's terms are only consistent inside of its bounded context. So, for example, pending in one bounded context could be a different, could have a different meaning than another bounded context, for example. And it also serves as an ownership boundary. So, for example, bounded context could be implemented and evolved and maintained by one team only. And a single team can, on the other hand, can also own multiple bounded contexts, but it's really, really relevant that not multiple teams are working on the same bounded context, because this enables autonomous teams working at their bounded context independently at their own pace and with minimal impact across other teams.
Yeah.
And it also serves as a physical boundary and can be implemented as a separate solution and can be deployed independently as separate artifacts, and also enables separate data stores which are not accessible by other bounded contexts. And for example, also the source code of each bounded context can be maintained in separate Git repositories with their own CI/CD pipeline. So, and also, each bounded context can have separate architecture patterns applied, and that's where we enter the tactical design area.
Right. And before we get to that, though, I just want to, because I think we hear this term bounded contexts quite a bit when we're talking about microservices, and this is exactly what we're talking about here. But that is certainly one of those things where when people move to microservices, it's always what is a bounded context? What does that mean? Why should I create a billing service? Should I create an inventory service? Should I create an alerting service? Where are the separations there? This is exactly what you want to follow, right? You want to think about all these different ideas. You want to talk about the language barrier. Like if you have two domains that are trying to work with one another, you don't put those into the same bounded context because the language could be different. The infrastructure could be different. All kinds of things like that. The physical boundary, the ownership boundary, these are all great things. So if you're thinking about building microservices, start paying attention to everything that Susanne is saying right now, because this is super important. Sorry, continue.
Yeah, no problem at all.
Hey everyone, I just wanted to take a moment to thank our sponsor, Hexagon. If you're running modern applications in the cloud like serverless and microservices, Hexagon can add distributed tracing and payload visibility to all of your workloads. It lets you discover, monitor, and alert on issues, plus you can search across every trace, payload, and log so that you can troubleshoot and solve the most complex issues in seconds, all through a single, easy-to-use web-based interface. It's also incredibly simple and fast to set up. There are no agents to install, no manual coding, no tagging, and no training required. It literally takes about 3 minutes to get this up and running. Then Hexagon will discover and instrument all of your application stacks with no coding changes. Now, I've known Nitzan, their CEO, and Ron, their CTO, for quite some time now, both of whom have actually been guests on this podcast, and they both bring an incredible amount of expertise to the observability space. The work that they and the team at Hexagon have done is amazing, and they've built a really, really solid product. So if you're looking for an observability tool that you can run on any of your production workloads, containers, Lambda, Kubernetes, Fargate, or even VMs, definitely check them out at epsagon.com. That's EPSAGON.com.
And each bounded context can have separate architecture patterns applied. That's what I was mentioning, that we enter now the tactical design patterns and practices. And for example, one bounded context can go with the layered architecture, where you split your source code into layers such as presentation, business logic, and persistence layer, or as hexagonal architecture, a specific form of the layered architecture. I come to this in a minute. Or, for example, or CQRS, command query responsible segregation, where you split your source code into command models and read models for updating the state of your domain model or reading the state of your domain model. So, and I would like to highlight the hexagonal architecture a little bit. I know that you have already covered this in a previous podcast already, but it's specifically also combined with serverless when you transform your value chain going from open source to for example, to serverless. It's really, and combined with domain-driven design, hexagonal architecture, it's really helpful because it aims for separation of concerns. It's also called ports and adapters. And what it does is it creates loosely coupled software components that can be easily connected to their software environment by using ports and adapters. And your software components are categorized into an outer and inner part, where your ports and adapters are used to connect from the outside to the inside and from the inner part to the outside. And its core, the inner part, there is the business logic. And hexagonal architecture makes your components exchangeable. And so no matter what kind of infrastructure you are using at the outside, the business logic at the inside can remain the same, and makes your business logic adaptable for future evolution. So, for example, when you started with your core domain using open source software like MongoDB and using Keycloak for authentication, something like that. So, and you are now shifting it to AWS using DynamoDB and using serverless Lambda functions to provide an backend API. Your domain-driven design, your domain model remains the same. So it's representing your business logic, including your rules, but the infrastructure can be exchanged and without touching the inner part of your system.
Yeah, so I mean, ports and adapters and the hexagonal architecture, like we did talk about that before, but this is a super important way to build software, especially with serverless. I started doing this actually after I talked to Slobodan Stojanovic. He was a big fan of it, and I said, I'll give it a try, because I would often build in a lot of logic right into Lambda functions, or you have some of those calls that aren't quite separated out. And I've always been a big fan of building like data access layers, right? So you always build some simple interface to your database so that you don't have to always be writing SQL queries or queries against DynamoDB or something like that. But this is great because it does help you evolve, right? Like, as you said, like if you are using MongoDB and then you decide, hey, I want to go to DynamoDB, forget about moving data, which is a different problem. But in terms of your software and the architecture that you build, or I should say the models that you build, those can stay the same, and then you just have to, again, sort of swap out that adapter and have it access, X database rather than Y database. So then how do you implement some of these business patterns themselves?
Yeah. So,
or I should say, how do you implement some of these business logic patterns?
Exactly. So each bounded context can be implemented by different business logic implementation patterns. So, for example, for our core domain, it could be implemented as a domain model related to our domain-driven design, with its building blocks of aggregates, entities, value objects, and so on. And so the domain model is an object model of the domain, which incorporates both behavior and data. And but it should not be applied to everywhere. So it copes very well with cases of complex business logic and complex business rules. And it's very well suited, as I mentioned, for implementing the core subdomain, which goes into Wardley Maps, into the Genesis and custom built evolution stage. And so the domain model should be free of technological and infrastructure complexities. And I come a bit later to the building blocks of the domain model. But I would also like to highlight other business logic implementation patterns that are possible. So there are a lot of, I just want to highlight two others, like the active record, for example. Mm-hmm. active records represent a row in a database table or view, and they encapsulate the database access and also adds domain logic to that data. And so it carries the data and the behavior and the access to the database itself. And so the active record supports cases where business logic is quite simple, but operates on more complex data structure. And it's very usable for the supporting subdomain and domain-driven design. So
yeah, that's what I was just going to say, is that a lot of that's one of the things that I think you mentioned earlier was you don't use domain models or core models for everything, right? Like that's the whole point of the build versus buy versus outsource type thing, is that you want to make sure that when there's something simple that needs to be done, like simple store a database record, and there's not a lot of complexity to that using something like Active Record is a better choice than trying to, because you don't want to reinvent the wheel, essentially.
Exactly. And you also, so if you try to apply domain-driven design to cases with less complex business logic, then you're over-engineering it.
Right.
And so domain-driven design is really very well suited for complex business logic cases. And these are supposed to be your core domain, right? Which is in the Genesis and custom build evolution stage of a Wardley Map. So there it fits very well, but domain-driven design, I would not recommend to use it for generic subdomain. So for example, they can use transaction scripts, for example, another business logic implementation pattern where you organize your business logic by procedure, and where each procedure handles a single request from the presentation. So it works very well with small applications that does not implement any complex business logic. And there you can just, for example, importers or authentication using Cognito or something like that.
Yeah.
So that's, you don't have to apply domain-driven design into that generic subdomain case.
So you mentioned the building blocks of domain models. So what are those?
Yes, and they could be kind of like overwhelming because there are a lot of building blocks. But I guess it's so. And if you start, like, it could be the case that you have the impression, my first model does not look very nice, and that's okay, because when you start at the beginning. The first versions, it's kind of an iterative approach, right?
Sure.
While you're collaborating with your domain experts, while you're gaining more knowledge, your domain model is evolving as well, and and also, like, you can't do it right from the very beginning, but that's at least my experience. I don't want to tell.
No, I think with anything, it's like designing a DynamoDB table. You're going to get it wrong the first time, and you just got to keep working through it till it. I mean, it's with all software. An iterative approach to anything is typically what we do, because we think we're better than we are, and we just make a decision, and then we realize, oh, that was a bad decision. A couple of weeks later.
Exactly.
So.
And you're always smarter after we have gained all the experiences, right?
Exactly.
Specifically with DynamoDB tables.
Right, exactly.
Why is it so expensive? So domain-driven design comes with building blocks, and I would like to highlight a few of them. So, for example, we have, I guess, the most simple building block is the value object. A value object is an immutable object which can be identified by its value, and when you change this value, you will replace the entire object instance. And for example, a common example that people are bringing us, like the address of a customer, that could be a value object. But I also like to go even more fine-grained, but I'll talk to that one later on. And the next building block is an entity. And an entity is identified by a unique ID, and it can change its state over time. So, like, that's something that comes. It's incorporated into an aggregate. So, an aggregate itself is composed of represents a hierarchy of objects, and it's composed of one or more entities and one or more value objects, and where one entity is called the aggregate root. And an aggregate root is designated as the aggregate's public interface that you can use, like when you use a domain model that is an aggregate. When you load it from the database. You are going through its aggregate root by its unique entity ID, load it into, and also apply then the, like renaming it or rescheduling or something like that that's applicable to the domain logic. That's usually then the aggregate roots methods that you are using. Then you also have the repository that can save and retrieve entities or aggregates from the underlying storage mechanism. And you also have an application service. These are only, their purpose is to only orchestrate use cases and manage transactions. So they do not contain any business logic, but they are the gateway to the domain model, to the aggregates that are building your domain model. And another thing is also the domain event. This is a message that describes a significant event that has happened in your business domain, for example. So there are a lot of like building blocks, and they are kind of like, really not really tangible at the very beginning. But the more you try to use them, for example, also like during a workshop, I was building a conference solution, and I tried to compose my domain model of aggregates, and the aggregates were composed of value objects, and each of them is taking care of keeping the invariance, the business rule, with its integrity, so that you can make sure, even though you might have a lot of classes and composed together with each other, and it says, why do I need so many classes? Because each of them is ensuring that that your aggregate composed of these components, of these value objects and entities, you can make sure that they are consistent and they are valid at every time in your system, because they take care of it. They take care whenever you compose it. At that time, they are valid. They have matched the validation restrictions, for example.
Well, I mean, even just object-oriented design. I mean, that software pattern of creating a new object that has a very specific structure and specific methods that can interact with it. It's very similar, I think, in a sense to what. Sort of what you're talking about with these individual bounded contexts, only a lot more complex, but that ability for you to, create these things and make sure that when they're created and the things that they can do, that these are all very specifically prescribed, like it's very restrictive in terms of what these things can do, so they can follow all those business rules.
Yes, and we also have, so for example, when your domain model that is composed of, it could be one aggregate, could be multiple aggregates, for example. And they are having methods, for example, that are really matching, consistent with the terms of your ubiquitous language. You don't have a domain model that consists just of setter and getters and changing state. Instead, they have methods that are reflecting the shared language. For example, if you have, for example, you have a customer aggregate, and the company name is changing. You will have a method that's called rename, and containing then the name as a parameter. Or, for example, when the address has changed, you're not saying, okay, set address. Instead, you say relocate or something like that. So that it's really reflected to the domain language, to the ubiquitous language. So when you talk to your domain experts, you share the same language, so that you don't have to translate your technical terms to the domain experts' terms. Instead, you're using the same language. And this also allows you to get rid of a lot of misunderstandings.
Well, and you had mentioned too, like that relocate. So let's say I have a function or a method that allows me to relocate a customer. It's not as simple as just saying, okay, change the address, right? Like there may be rules in place where you have to keep X number of past address, or you have to make sure you keep all addresses, or you can only relocate a customer if if the customer is active or if they've been
Yeah.
active within a certain amount of time.
Yeah.
So all of those business rules, all of those things that tie together with that domain model, all of that ties together with these with these methods that you talked about. So I think that is, I think that's super important for people to think about it that way. It's not just update a record in the database.
Exactly. It's also like it's also matching the invariants, the business logic, the business rules.
Yeah, that's important. All right, so if we want to use domain-driven design, how can we use it to help us build, say, serverless like backends, for example?
So when I entered the field of serverless, I was with its fine-grained, short-lived function triggered by a variety of events, and I was kind of like overwhelmed in terms of if you design a system composed of countless functions. That might be the risk of losing sight of each function's purpose. Or it also bears the risk that we accidentally introduce a big ball of mud due to coupling functions together by accident or accessing resources that we should not access from various functions itself. And one approach to could be to introduce domain-driven design. Because domain-driven design allows you to organize the serverless functions, the Lambda functions, for example, if you build a backend API. Mm-hmm. So it allows you to organize your functions together so that you, as I mentioned, like bounded context provides different forms of boundaries in terms of like also physical boundaries, like that you, for example, can organize all your function that belongs to one bounded context, your modular your module in terms of like your system, and it allows you to organize your functions, for example, that they all go in one Git repository, for example. Yeah. And it also allows you to organize your Lambda functions. If you go on AWS, it allows you to organize them in terms of like what access rights do I have for my for the DynamoDB table, for example, that I'm using. So only those functions that goes into one bounded context and are located in one Git repository, they are allowed to access the DynamoDB table that is saving the state of our domain model, but not other serverless functions that are relevant or that are responsible for another bounded context. They are not allowed to access my DynamoDB table directly. Instead, we have to figure out like what kind of integration patterns we have between these bounded contexts, like event-driven, like for example, submitting an event or into an SNS topic, and our other bounded context, external bounded context, is subscribing to this topic and then is reacting on this appropriately, but it's not accessing the data storage components of an external bounded context. So that allows us to get an overview which serverless functions are solving what problem, what part of our problem, what bounded context, and they help us to organize which functions goes into one Git repository, and also help us to organize what access rights do we have, and that we are not allowed to access resources that are in where other bounded contexts are in charge of.
Right, and that actually creates sort of that physical boundary, right? I mean, in a sense where you can have, physical boundaries and ownership boundaries that we talked about earlier, because you can have a team that goes and just works on one bounded context and a group of functions. And I think we've been seeing that quite a bit. That's sort of been the approach when people are taking a microservices approach to serverless, that what they're doing is they're taking a single stack and they're putting all their related functions for that service in a single stack, have a separate DynamoDB table or other, whatever their data store of choice is, that they're sort of doing that. So I think that makes a ton of sense. And certainly the domain-driven design approach to all of this and really thinking about that ubiquitous language. I know I'm hung up on this, but that to me is hugely important because I think a lot of people miss that. And I think, as you said, sort of what's important for the customer is the most important thing. And I know a lot of technologists who say, all right, we just want to focus on what's good for the customer. But what we really want to do is figure out how to install Kubernetes, right?
Exactly.
We want to figure out how we can do this cool technological thing, whether or not, it eventually will have some benefit to our customer. And that's that's I think what slows down a lot of software. And I think what you said right from the beginning is that's why we have so much poor software. So anyways, if people want to learn more about domain-driven design, I know there are some books out there, but you're working on a workshop for this, right?
Yes. Yeah, so I have created a workshop that is still under development. And so I have created a workshop that is focusing on an example, because I guess you can learn the when you have a practical example.
Sure.
It's also a simple example, but it's, for example, a conference solution. Where we identify the bounded contexts that are necessary to, for example, manage a conference event, including starting a CFP, a call for papers, evaluating the submissions, and create a schedule, and to submit a session proposal from the speaker, and something like that. So and this I was creating a workshop out of it in terms of how to use. One thing like how to use Wardley Maps, how to identify what shall be core domain and combine it with domain-driven design, and what goes into to the other evolution stages, and also evolving the value chain, going first from, what happens when we implement this solution, using also the tactical design patterns after we have started with the strategic design. But how can we evolve the value chain in terms of starting first with an open source solution going on premise, and how does it evolve going then at the end to serverless, providing a serverless backend API with micro frontends, for example. And it's a kind of multi-stage workshop where we try to going also from the strategy, how can we outsource those components, and what does it mean for our software architecture and our software design, and what kind of impact does it have. And then at the end we figured out, so the business logic remains the same, but in the hexagonal architecture, but the infrastructure components, they are then replaced. For example, in one case, we are using a REST API to communicate with another bounded context. And for example, in the serverless example, I'm using then an SNS topic for asynchronous communication via events, and still the core, the inner part remains the same. And I try to make it tangible for the audience, for the participants, how it looks like, evolving your value chain.
Awesome. Well, that's going to be a very, very good resource. So thank you for putting that effort in, and thank you, Susanne, for coming on the show and talking about this, because I think this is something that isn't talked about a lot in a lot of development on a lot of development teams, and it should be more, because we would be building better software. And of course, I'm quite fond of serverless, right? So the idea of the things that you can do to reduce that build or that sort of implement yourself type projects is something that serverless just blows everything else out of the water, at least in my opinion. So anyways, thank you very much for coming on the show. If people want to get in touch with you or find out more about your workshop and some of the other things you're working on, how do they do that?
So they can contact me via Twitter, for example. So my Twitter handle is SUKSR. So also my direct messages are open. And also I am having my own website. It's www.susannekaiser.net. And also you can reach me over LinkedIn as well.
Awesome. I will get all of that into the show notes. Thanks again.
Thank you.
And that's this week's Serverless Chat. I want to give a huge thank you to Susanne Kaiser for being my guest this week, and to our sponsor, Hexagon. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/42. For more serverless chats, subscribe, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_Daily. And if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.